Hi, everyone. Welcome to episode number 3 of Deep Papers, where we interview AI scientists on the latest and most interesting AI papers. I'm joined by Timo and Thomas from Meta AI. They've worked on Toolformer, which is a paper that teaches language models how to use external tools like calculators or searching the internet. Before we dive in, does everyone want to do like 15-second intro? I'll start. My name is Brian. I run this Twitter account called AI Pub, covering technical AI topics. I run this podcast, Deep Papers, and I also refer software engineers, AI engineers, and ML engineers to AI startups.
I'll give an intro next here. Jason from Arize AI, one of the leaders in ML observability. Great to have everyone here.
And hey everyone, Aparna, also co-founder of Arize. Excited to be here today.
Hi everyone, I'm Timo, a research scientist at Meta AI and one of the Toolformer authors.
Yeah, hi everyone, I'm Thomas Scialom, one also of the research scientists working on the Toolformer paper. Thanks for the invitation.
Cool. Just to kick it off, do you guys want to give the elevator pitch for Toolformer? Like, what did you guys do? What are maybe the coolest ideas? Why should people listen and be interested in what you guys have done?
Well, I would say if you play around with one of those recent very large language models, they can do all kinds of amazing things. But there are also some limitations that you kind of can find very clearly when you just play around with them for a few minutes, mostly because they're not connected to their external world. But there are also some skills that humans find very easy that those models just can't do. And so a very natural way of making them able to connect to the external world, do calculations and all kinds of things, is to just try and equip them with the ability to communicate via APIs, via external tools. And that is basically what I would say this project is about.
Timo, can you go a little deeper on just what are these limitations? I mean, we see examples where ChatGPT can't solve basic math problems, but can you give some examples of what motivated you all?
I think like one of the big motivations is obviously, having up-to-date information about events. That is, I think, something that people want very often when they chat with models. They want to have comments about things that happen in their daily lives. And this is something that clearly those models can't do when they're not connected to the external world. You don't want to retrain them every day. So I think that is one of the biggest things. And then there are other things like, for example, calculations and translation that those models theoretically can do, but it just needs a significant scale and very, very strong models to do that. So using tools in those cases is a way of getting similar performance, but with much smaller models. And then there's also all different kind of things, like if you want to do some complex tasks, you might want to have, let's say, a model that can execute some kind of code maybe, or you want the model to get some context about you personally when you ask questions. And I think fundamentally all those issues could be addressed with different kinds of tools.
Cool.
Maybe let me give an example just to illustrate. Like I played with ChatGPT like yesterday, and I asked to make a code to lower the input, the string input, but not the first letter, because it should be remain upper. And like ChatGPT write a code .lower, which lowers everything. And they said as a command, this is the code you want, print the input, and it expected to have the correct output. If you just execute it, you will see that it's not the correct output. And we can do that as human to test and debug and iterate. Just giving access to that, to those models, will unlock a lot of capabilities.
Got it.
And what do you think in terms of like the areas, you have a couple in the paper of places where the models today aren't great, calculators, for example, or time-based stuff. Like what are some of the heavy hitters right now where you see some of the large language models really struggling? Those seem two obvious ones, but is there a broader set of areas. And what do you think those areas, any insights to why, I guess?
I think Timo mentioned updated information.
Yeah.
And even like more general than that, in the sense of the notion of time, what happens when, before, yesterday, and why. I mean, obviously the training objective self-supervised or anything. You extract a paragraph randomly, you shuffle all your data. You don't provide any information about when was written this paragraph. You don't have any metadata. And so you can't expect the model to learn that. What if we give access to this kind of knowledge to the model? Maybe it could just simply work as that.
Cool.
Let me also give one more example of one of those like abilities that those models don't have. So we have like temporal awareness, updatability, doing math. Another thing that you won't find in the Toolformer paper, but that I would still believe is one of those things that tools could address. The way those models work based on transformers, with their quadratic time complexity self-attention, they usually can only look at a limited context window. Usually they can look at, I don't know, 4,000 or maybe 8,000 tokens, but nothing beyond that. And you might think of many cases where that is not enough, where you have a long document that you want to ask questions about or that you want to work with. And I think this is also something where you could think of tools that allow you to somehow, search in the document that you're currently operating in, or do some other operations to address that limitation.
Yeah, and in this direction, like I mentioned earlier, I think you could even imagine the model itself as a tool, and so it can call itself recursively to first take some notes of something it's writing, then provide the notes and like call recursively, backpropagate the information. And so like a human, like basically dividing the task in subtasks and propagating the answer and execute.
Gotcha. One thing I wanted to ask, I mean, I think in some sense the main meat of the paper, like a lot of the core, the most interesting idea is actually how you generated the data set. But I think before getting into that, I think just for the audience's sake, could you guys run through how a language model actually uses these tools? Because these language models, all they do is they just they take the context and then they spit out the next token, right? You add it in the context, you spit out the next token. So how does a language model use different APIs, just given that all it can do is just spit out the next token?
Well, in the current version of the Toolformer, we have like one limitation that we impose upon those APIs, and that is they need to be text to text. So the input that you give to those APIs should be representable in some way as text, and the same should be true for the output. And basically how those models can then call tools is they would first generate text as long as they want, and we allow them to generate one special token, one special kind of word that would signalize, now I want to call an API. And after the model has produced this kind of token, we then do some kind of a constraint decoding where the model first needs to specify which tool it wants to call, and can then also specify the parameters it wants to call. And then it will finally produce another token which says, now I'm done, now I want to get the result. And this is basically where we interrupt the decoding process. We stop it from producing any further tokens. We do that API call. So we call our calculator, or we look something up in our calendar, we do a search. We get the result from that, which is also a piece of text. And we then just put that into the string that the model has already produced. And after that, we let it continue writing text.
Cool. That's a great explanation. I think reading through the paper, I got a little bit stuck, and I had to just stop with a pen and paper and kind of write down each one of these steps and think about like, oh, step by step, like, first it generates the API token, then you generate the request, then there's the call API token. So I think, if the audience trying to get a little bit deeper in this stuff, I do recommend like thinking about this step by step. I guess no pun intended.
In terms of like mixed, there's a lot of papers the last couple of years of like mixture of experts type scenarios. How does this compare and contrast with some of the work done, and is this the future of that?
I think there's a direct connection. In the future work, so I'm also one of the authors of Galactica, which was kind of the large language model for science.
Yeah.
One of the future work we plan could be like to connect Galactica as a tool to leverage an expert in a domain, here science. And so you could see it as a mixture of experts, but via API calls. And so somehow calculate it's just a more general paradigm where Galactica is an expert, the weights of a language model experts for science, but a calculator is just the expert for calculation. You don't need to have weights for expertise.
Got it. What was, why start with the set of, tools that you guys started with? Was there a reasoning of like, the question and answering one, the calculator one? Was that kind of just like, in what other tools do you think this can be expanded into?
Oh, I think when it comes to why we chose this particular set of tools, one of the things we wanted to do is we wanted to work with a publicly available language model. And that means by today's standards, the language model is relatively small and not as capable as some of the models that people might have experience with. So what this means is the tools could not be too complicated. Like, for example, writing Python code might be something that this model isn't good enough at, that the approach would work. So that was one criterion, trying to find tools that are not too hard, always relatively clear how you could use them. And the other thing is, obviously, we wanted to try tools that address some of those fundamental limitations. You can think of a lot of tools that are very specialized, and that would be helpful in very specific circumstances. We tried to find tools that are somewhat general. And I think that is the main criteria. Obviously, we also wanted them to be kind of diverse. So you can see we have one tool that is based on a language model, one tool that uses BM25 retrieval, one time we have a calculator. So we just wanted to see whether the same approach can work for different kinds of tools that are very diverse.
Yeah.
I think this paper is like just a first step in this direction. And so we wanted to maximize the diversity of the tools. We see there's a lot of things that could come now. And so it's just a proof of concept that using tools and diverse tools, like a translation, calendar, search, local search, or like global search with information trail will work. And now that we have proved this concept, there's a lot of things to explore.
Yeah, I mean, I think, there's that, I don't know, people always say, man became more than an animal when you gave them, built fire, and there's tools and being able to leverage that. And this feels kind of revolutionary in that same way for LLMs. Where do you think this goes? Like, what other tools do you think, you would explore next, or you feel like this can eventually go to?
Yeah, maybe I can answer from a long-term perspective.
Yeah.
Very long-term, not short-term. Any tools, which will mean also actual active actions in the world, writing a message at Stack Exchange to ask other, possibly humans or machines, to answer you. And humans could be like some tools, like it's just an interaction with the external world, where we started with very naive primitive tools, but you could have access like to the whole world, to, I don't know, an Excel sheet, whatever tools you're actually using on your daily basis could be a tool. And like communicating with humans, you want to book a plane, you will do some search and you will do a summary. Maybe you will ask some additional information or clarification to someone, which could be a human. And so just the same way you have an API, you can send a message, which is an API, receive the feedback, etc. So that, I feel like, paves the way towards like a future where the LLM can be an assistant, an agent, to act not only passively, but maybe in the very long term, more actively.
Gotcha. I wanted to talk about the data set, or how you guys generated the data set, because somehow, at least from my perspective reading the paper, like this was the most interesting part, or is kind of some of the key ideas. For background for the audience, the problem with, or and I don't mean to speak for you, please correct me, but one of the main problems with training these tool transformers is getting the right data. So you get something like GPT-3, it's trained on huge swaths of the internet like Common Crawl, Wikipedia, etc. With training something like Toolformer, the text has to be annotated. So not only is it text, maybe it's a script from a movie or a play or a Wikipedia article, but there has to be certain points in that text that say, hey, right now call an API, and here's the API call that you're going to make to the API. So the problem, or one of the problems with this is getting like a huge annotated data set, not just of text, but also of points in that text where the Toolformer needs to call the API. And part of the problem is you can't, because the scale of these text data sets is so large, like Common Crawl, you can't just pay human labelers to do it. So there's kind of a setup where you have to generate this huge kind of API annotations, but you also have to do it in a kind of automated way at scale. With that as the setup, like, how did you guys do that? What are the key ideas? Because I thought it was super clever how you guys ended up like generating this annotated data set.
So I can maybe quickly walk you through the process on a high level. Like, one of the things that were very important to us, as you said, we wanted to avoid having huge costs from humans having to annotate data. And also we wanted to find an approach that works with whatever data set you care about. So if you have a specific data set that you want to train your language model on, we wanted to find some way of using that specific data set and adding tool calls to that. Regardless of whether it is general language modeling or a instruction tuning data set or some very task-specific data, that was kind of one of the premises that we worked with, that we want to make this happen. And then the basic idea is that we proceed in 3 steps. The first one is we just take this large piece of text that we want to annotate with API calls, and we use a language model to sample a massive amount of different API calls. The way we do this is we use the in-context learning abilities of pre-trained language models. What that means is basically if you show a pre-trained language model in its context window 3 examples of inputs and corresponding outputs, it can often do a relatively good job at creating an output for the 4th input that you would show it. And so for each API, we give the language model this prompt where we say, you have access to a question answering API. You should annotate text with API calls wherever you think those might be helpful. Here are some examples. And then we give it 3 examples of an input, and the corresponding output would be the same text with API calls inserted. And then we ask the model to do the same for a 4th text.
Can I actually just interrupt at that step? Just for the audience's sake, just to like give them a sense of how this works. I mean, now that you're talking about this, I think like one way to think about this is you want to have human labelers do all of this. And in some sense, you're just using a language model as the human labeler. But I just wanted to read one example for the audience so that they got a sense of like what this is like. So the input here is Joe Biden was born in Scranton, Pennsylvania. That's like the piece of text that you want to be annotated with API calls, but isn't. So what you feed into the language model to label it is, first, there's a prompt. Your task is to add calls to a question answering API to a piece of text. The questions should help you get information required to complete the text. You can call the API by writing bracket QA parentheses question, where question is the question you want to ask. Here are some examples of API calls. Input, Joe Biden was born in Scranton, Pennsylvania. Output, Joe Biden was born in bracket QA, where was Joe Biden born? Scranton, QA, in which state is Scranton, Pennsylvania? So you give a couple examples in there. I just wanted to read that to the audience in case it makes it a little bit more clear what the model is doing.
Hey, Timo, one question I had reading through the paper on that was, when would the model know to call a tool versus just, how does the model know? This is an area I get it wrong, so I should use a tool here.
I think the key thing is that at this step, the language model really doesn't know. So what we kind of do is with this entire process, we just massively oversample API calls. And now if you give a language model those examples of inputs and corresponding API calls, it will start generating API calls for new texts, but they will very often be at the wrong place, or they will just ask for information that is completely irrelevant. Like in general, what we observed is that depending on the tool, between 90% and even 99% of all API calls generated were just completely useless. So this is kind of something that we need to live with at this point. Obviously, as you move to better models, as you move to bigger models, that might become a bit better. But with the model that we experimented with, a lot of the API calls really don't make any sense at all. We have I think we have a figure or a table in the paper where we show some of the good and some of the bad API calls. That will give you, if you look at that, an idea of how bad those bad API calls are. And those are by far the most, as I've said, 90 to 99% of them are really, really bad.
So yeah, I guess, follow-up question is moving forward, so you really don't, now you're making this data set, you really don't want to train your model on lots of crappy API calls. So what do you guys do to, handle whatever 90 or 99% of the API annotations that you've generated to actually only include the good ones? What do you guys do?
I think, to me, this is maybe the most interesting bit of the paper, because obviously we want to find some way of distinguishing good from bad API calls. We don't want to have humans involved at that point, because again, that would be super expensive. And also, which API call is useful really depends on what you already know and who you are. So for example, as a human, you might know where Joe Biden was born, and you'd say, oh, I don't need to call an API at this place. And maybe a GPT-3 model also knows that and says, I don't need to call an API. But maybe a much smaller model like GPT-J doesn't know that and needs to call the API. So what makes a good API call? I don't think there's a universal answer. I think it really depends on what you already know and what kind of information you still need. And with that in mind, we said, okay, our idea is we'll just try to measure whether this API call is helpful to the language model itself in doing its actual job, which is just continuing the text and producing the next few tokens. So what we do is, given an API call, we look at the next few tokens that come after the API call. And then we look at the probability that our language model would assign to those few following tokens if there was no API call. And we compare that to the probability that it would assign to those next tokens that we know to be correct if we do the API call. And only if this probability increases by a certain threshold when we do the API call, that's when we say, okay, apparently this API call is helpful because it made it easier for the language model to predict the next few tokens. And this is basically what we use as a filter criterion.
Interesting.
And
Yeah, so
I think this is extremely strong idea here, Timo mentioned, because you can think about one of the limitations, in my opinion, of self-supervised learning, that I like to think about the self-supervised learning, the paragraph, the text. We try to predict some tokens based on the context nearby as they're kind of the log of the thoughts, but only the logs. And there's a lot of hidden context that we don't provide. If you ask me a very complex calculation, maybe we'll just ping on my calculator and give you the answer. And if you train the model to predict that directly without the calculator, it's arguably something very hard, which actually maybe even amplifies the hallucination problem. Because with the lack of context, you are asking, if you have a left to right model, the king of France was, and you don't have any more context because maybe the date is after, etc. Arguably, you are emphasizing for hallucination. And so maybe adding the tools here help to capture some of the hidden parts of the reasoning for the context, additional context. I like to see it as an additional context. So in that sense, it could also prevent one of the major limitations of self-supervision.
Yeah.
Last question on this train. So cool. So you've generated this massive amount of API calls to annotate your data set. They're not very good. You filter them using this kind of clever mechanism. You cut out 90%, maybe 99% of the bad ones. Now you have a data set that is annotated with these API calls, what do you do? How do what do you do after that? Like how do you actually use that to, get the language model to use the tools?
So like there's two steps here. One of them is very important. We like all of that filtering we do for each API separately, but then obviously before we use the data set to do anything, we merge all those API calls. So that means even though we generate the API calls independently, in the end, we end up with a data set that contains different API calls for different APIs, sometimes in the same example. So we really have this nice mixture of different APIs in one data set. And then the final step is actually very, very simple. We just train the language model for a bit longer on this new data set with API calls. And because we selected our data that we annotated the API calls ourselves, and we can basically use whatever data we want. In particular, we can also use the same data that the model was trained on in the first place. So if we do that additional fine-tuning, it won't lose any of its generality. It won't like unlearn things that it learned during pre-training, because it's still the exact same data distribution. The only thing that is new is that now it's trained on data that contains those API calls. And as we discussed earlier, of course, we have those special API call tokens in there and the token that says, now I want to wait for the result. And so by just training on that data, the model automatically learns to call those APIs. And because it generated the API calls itself and it scored them itself, it will only do them at exactly those positions where it really thinks that they are necessary and where there's useful information to be expected.
Interesting.
Super cool.
In terms of the areas that you think improve and where you look forward to improve, or what do you think the next, what does the future look like? What are the next areas of research that you're excited about, or just that you could talk about, or where do you see this going?
Well, I think obviously one of the obvious next step is to have multiple tools and multiple steps of calling the tools, which was one of the main limitations for this first paper. That's clearly the next big thing. I don't know if you want to add more, Timo. There's many more things to do, but that's the one that seems the most obvious.
Absolutely. No, I think in general, like given that all of our API calls are created independently, as Thomas said, you won't find examples where the model first uses the one API, then uses that information to call another API, etc. So that is obviously something that I think would be interesting to study. I'm also personally really interested in that idea of having language model, that maybe the model itself as a tool. So like you could just say, okay, I need to do a bit of reasoning about something before I get a response. So I want to call myself as a tool in kind of reasoning mode, prompted in a particular way, and then use that result. And in particular, if the model calls itself, then you basically get for free those kind of hierarchical chains where the model that called itself could again call itself, or it could call another tool. And so that allows you to have much more complex interactions with those tools, which I think would be very interesting to study.
Very cool. I had just one last question on all of this, just kind of similar question. Where do you think products are headed? So like what kind of products do you think will use these sort of ideas or use these methods? There's obviously like Bing. I think Bing already has some of these things built in, but I'm curious if there are kind of other things that come to mind.
Yeah, maybe Bing read our paper. I don't know. It came after, but no, I was saying joke aside, but maybe a second joke. I mean, AGI, we use our Toolformer paradigm.
Yeah.
I mean, no, I think the future of large language model, at least, will definitely be about now that we have at a level where it's good enough. ChatGPT obviously has shown that, and it will get better and better. The main thing is to interact with user, with tools, with API. And so that's clearly, I think we are at a level actually where this becomes reliable at a product level to deliver some value in terms of business.
Do you think people were, I mean, hypothetically, in a world where people are using these and calling tools and using it to take actions, do you think there's some constraints that you'd want to put in to what kind of calls can be made? Will some calls be, if you're, let's say, going through and you have access to some historical database or something and you're querying it, you can harm user data. Is there some constraint? Have you guys thought about things like constraints on what type of tools and access to tools that you could give it?
So I think like for the current version of Toolformer, we deliberately chose tools where this is not really an issue. I think this is like even more pronounced when you get from this kind of passive tool use that we have right now, where you just use the tools to get some information, to what Thomas described earlier, where you want the model to act, where you have kind of tool use that actually changes something in the world. And I think at that point, it becomes like a really a problem that we need to think a lot about and be very, very careful about what kinds of abilities we give to those models and what we really want them to do.
Got it. So once it's past the passive to more actions from those tools.
We had a few words about that in the survey we also recently released with Timo about acting and reasoning survey for large language model. It's very short, but we already mentioned that when we become to active modes, it starts to be more concern. And there's a lot of more work to do there. But I wanted also to review a bit more technically about the constraint, word that occurs to me, in the sense that right now also one thing we are not doing is that there's some tools that takes a lot of time and some tools that are kind of for free. And right now, it's also a matter of compute. And arguably, using even like a large language model itself to do chain of thought and reasoning to obtain a calculation is much more inefficient than just coding a calculator. And so having given a sense of that in the loss while training the model is also part of the future work, where we'll give the sense of the constraint to use a tool, such that there's some tool that cost a lot, some tool that cost less. Using it, coding itself has a price in terms of compute. And I feel like we could see very interesting emergence doing that.
Interesting.
Does anyone kind of have any final questions or final things to add?
That's great. Well, thank you for joining us.
Well, actually, I have one more question then. If where should folks listening like follow your work for future updates, and where can they learn a little bit more about Toolformer if they want to?
Well, I'd say for Toolformer, at least from our side, unfortunately, there isn't anything out there yet besides the paper. We were thinking about writing a blog post maybe to make it a bit more easy to understand, but I think we're not super near to having that. So I think in general there isn't that much out there that we produced ourselves. I know there's some like videos out there trying to explain the Toolformer. Also, I've seen some blog posts. So I think just searching for that a bit will give you a lot of more context. In general, I guess if you want to follow our work, just checking academic Twitter is always a good place. But apart from that, I don't really have any very good recommendations. I don't know, Thomas, maybe you have some more ideas.
Yeah, just follow Timo on Twitter.
Well, thanks so much for joining us. This was a lot of fun. It was really fun for me to read the paper, and even more fun to chat with you guys about some of the main ideas. Just thanks for your time. Really appreciate it.
Yeah, thank you so much, Timo and Thomas. Excited where the work goes next.
Thank you so much for the invitation.